Hello all, today in this video I am going to provide a demo video for sigmoid SVM, that is SVM with sigmoid kernel function. Already with the previous video we have worked with the linear SVM. In this code we are going to work with sigmoid SVM and going to make a comparison that with SVM is going to prove better results. For that we have used the data set which we downloaded from Kaggle. If you give like heart disease prediction in Kaggle means you will get the link and you can download from that. It will be having nearly 14 entries. In that the first 13 entries we will be using for the x variable and the last one entry we will be using for the y variable, and we are checking the data type for this data. Then we are getting whether this data is having any null entries. Since it is not having any null entries or missing values, we are not moving with any pre-processing algorithms. If we are it is having any null values or missing values means we have to work with pre-processing. And then we are getting the shape of the data set, and also we are making a plot by using the target variable, which is the y variable. It is having nearly 0 entry and 1 entry. We are just making the plot like which entry is higher and which entry is lower. So more or less in this case both are more or less it is same only, but 0 is little bit less. Then by using the test split function and by the use of the x variable and y variable with the test size of 0.2, that is 20% for testing and remaining 80% for training, we are determining the variables like x train, x test, y train and y test. And then by using these variables we are first making our linear kernel algorithm. For that we are using the library which we needed for SVM, and then we are making the kernel, specify the kernel function which is linear. Then we are using to train our algorithm. Train is done by using the fit function and testing by using the predict function. And also with the training function we are using the training variables like x train and y train. And also with the testing function we are using the text variables like the x test. Then we are determining going to display our confusion matrix. Already we have displayed the confusion matrix for the linear kernel and also the classification report for the linear kernel SVM. We have got 88% accuracy. In this code we are going to work with the sigmoid SVM, sigmoid kernel. For that we have here no need to determine the library. Why? Because the SVM is same only, but we are making a different definition within the SVM function, that is the kernel. Previously we used it as linear, now we are using as sigmoid. And then as usual we are moving with the training and testing. Training with done by use of the training variables and testing is done by use of the testing variables. And then we are determining the confusion matrix. Then we are here, you can notice only we are getting some previously the shape of the data is nearly 100,000 something, but here we are getting nearly some variables only. This is because we are using only 20%. The confusion matrix is plotted by against the testing values, and the testing values uses only 20% of the original data, so only this value drop. And also for the classification report also we are taking by use of this uh, test function only, and here we have got an accuracy of 52%. Now we are making a comparison. For the comparison we are making a variable called models, and within the models we are calling the linear SVM and also the sigmoid SVM. Then within we are making a for loop. Within the for loop we are calling this variable models, and also we are making a training function, testing function, and also we are determining variables like accuracy, mean square error, R2 square error, and then we are displaying the training accuracy and testing accuracy of linear kernel SVM and sigmoid kernel SVM. You can notice from here itself, linear kernel is only providing better results when compared to much more better results when compared to SVM. This thing which we are making in a table also, within the table we are making some highlighter points. We have set some highlighter points. Within the highlighter points, the model with the best accuracy or the highest accuracy will be shown in green color, and the model with the least accuracy will be shown in red color. So this is the code for linear sigmoid SVM. In the next video, we will be working with some other SVM kernel and will make a comparison that among that which kernel is providing the better result. Thank you.